Hello everyone, this is Andrea D'Angelo, one of the authors of ERASURE, a machine learning framework for reproducible research. Today, together with my colleague Claudio Savelli, I will showcase some of ERASURE's main features, functionalities, and motivation. I would also like to thank the other authors of the paper, Gabriele Tagliente, Flavio Giobergia, Elena Baralis, and Giovanni Stilo. So ERASURE is a machine learning framework. We define a machine learning task in the following way. Given a trained model M and a subset of its training data DF, which we will refer to as a forget set from now on, we want to remove the influence of the forget set from the model. So machine learning is a task of transforming the model M into a new model M prime such that M prime behaves as if it had never seen the forget set. This is the main goal of every unlearner method in the literature. ERASURE is focused on reproducibility. What we mean by that is that in order to run your experiment, all you need is to configure a JSON file. So a JSON configuration file that you can then share with everyone using ERASURE will yield the same results every time thanks to our seeding system. This is made in order to enhance reproducibility throughout research groups. So for our scenario, we will consider the Celebay dataset, which is made of thousands of images from celebrities. We imagine that under the provisions of the AI Act in Europe, some of these celebrities decide that they don't want to be part of the training set of any model anymore. We will identify them through their ID in the Celebay dataset that you can see on the right. We will consider a binary classifier on the smiling attribute. So just to sum up, what we will have as an X for our model is a collection of photos of celebrities. Our Y will be a binary label of whether the person is smiling or not. And the set label will be the IDs of the people that decided they don't want to be part of the training set of our binary classifier anymore. So now in order to implement the scenario, we will see an example configuration file in ERASURE written in JSON. I will now quickly go through the main sections of a JSON configuration file for ERASURE. So as you can see, the main sections are data, predictor, unlearners, and an evaluator section down here. We also have some global parameters that we will see in a second. So inside of the data section, we specify the data source and whatever preprocess the data needs to go through. In the predictor section, we specify which predictor to use. In our case, it will be a binary classifier, its loss function, its optimizer, and you can see that we can import this directly from PyTorch just by specifying their path in the JSON configuration file for ERASURE. In the unlearner section, we specify a list of unlearners that we want to use in this experiment together with their parameters. And lastly, in the evaluator section, we specify which of the metrics we want to measure during this particular experiment. Lastly, the global parameters are either cached, like if we want to use our cache or not, and the seed that for reproducibility reasons is directly inside of the configuration file that can then be shared in order to obtain the same results across multiple ERASURE instances. So my colleague Claudio Savelli will now go through a deeper inspection of this configuration file.
Thank you, Andrea. Hello to everyone. I'm Claudio Savelli, one of the authors of ERASURE, and in the second half of this video, we are going to take in consideration a full experimental unlearning pipeline through our JSON configuration file. The experiment that we are going to analyze now is the same that we have described in the first half of the video. The first building block is the data building block. In this building block, we can define our data source, that is Celebay in this case, and apply some preprocess to it. In this case, the preprocess that we apply to our dataset is just to choose which one will be the classification labels that we are going to use, and in this case is the isMining attribute for Celebay, and the Z label, so the one that we are going to use soon for the partition division. In this case, the identities of the people. In fact, with this experiment, we wanted to test a real case unlearning scenario where different people have requested for the deletion of their data. In the partition, through the data splitter methods, we can divide our dataset in different partitions. We have in this case 4 partitions, the train and the test one, and then we divide the train partition in the forget and retain one. As you can see, the forget set is built through the Z labels that are the identities of the people that we want to forget for this particular experiment. Now let's move to the predictor. In the predictor, we have all the necessary information to build our model on which we are going to apply the unlearning later on. In fact, we are going to select our model, that in this case is ResNet 18, and at the moment in ERASURE Erasure is compatible with all the PyTorch model, so also the transformers from models from Hugging Face, and we can set all the parameters that we need in order to make the training loop. So the number of epochs, the optimizer that we need with its own parameters, and the loss function that we need with its own parameters. Now let's move to the main building block of Erasure. As you can see, we have different unlearning methods in this case, a list of them, because what we want to do in this case is from the same predictor test different unlearning methods and see which one is the one that will perform better. At the moment in Erasure we have 13 different unlearning methods implemented that we took from the literature as the most popular ones. And the very interesting thing about this is that, as we already said, we put in the first position in the implementation in Erasure, on one end, the reproducibility, and we can have it through the seeding system that goes through all the training and unlearning process, but also the resource optimization. In fact, thanks to the caching system that depends on the seed, we can train only once our predictor and apply to it also in different times all the unlearning methods that we want without having to retrain from scratch every time our starting predictor. Now let's move to the final building block of this experiment, that is the evaluator. Usually, to evaluate an unlearning method, we want to test three different things. The first one is the efficiency that we have with respect to retraining from scratch the model. And in Erasure, we can do so through the evaluation of the running time or by counting the number of floating point operations. Then we have the accuracy, so the final utility of the model. And we can apply all the accuracy measures to our final models thanks to the implementation of the full scikit-learn library. Then the most peculiar things that we have to evaluate, of course, in an unlearning pattern is the efficacy. So how much we forgot actually about these identities. We have implemented in Erasure different state-of-the-art metrics that are well known in the literature, such as the unlearning membership inference attack, the relearning time, the anamnesis index, or the adaptive unlearning score. So this is Erasure. I want to thank you all for the attention through all the video, and I want to wish you a good day. Goodbye.